Hey everybody. Whoa, that's loud. Right, there we go. Hey everybody, welcome. As I said, we're going to talk about how we as Microsoft have done our DevOps transformation over the past 7 years or so. So this is going to be very much sort of people and process and all the hard things. The technology is fairly easy, and we've got that all kind of sorted. If you want to learn about the technology, there's another session ongoing right now in 310, I believe. But yeah, and then for the people on video, you've come to the right place, so thank you very much. So, my name is Martin Woodward, Martin Woo at Microsoft.com. If you want to send me abuse on Twitter, then please shout at Martin Woodward. And visualstudio.com whack DevOps is where I live. I've got a very grand title of Principal Group Program Manager DevOps. So, let me break that down for you. Principal Group Program Manager means I delete a lot of email, yeah? And DevOps means I delete a lot of email with PowerShell, okay? So that's what I do all day long. I live in a great part of the world, Northern Ireland. As you can tell by my accent, I'm not very local. I live in sunny Northern Ireland. This is the view from my office, which is pretty awesome. It's great in Northern Ireland. It's very green, but it does rain all the time, so we get a lot of cool rainbows. And there's the odd problem as well. I was doing a talk a few weeks ago, and just as I was about to go on stage, my wife sent me a text message to say there were goats eating the garden. So, it's not all sunshine and rainbows living out in the middle of Northern Ireland, but it's cool. Microsoft do give me an office in Northern Ireland. It's one of the perks you get. So that's where I work normally, but this is where they gave me the office. As you can see, there's a reason why I don't work there all the time. It's an industrial wasteland. Just in case you're ever in Belfast, Northern Ireland, that's actually the big pointy building at the bottom is a cool museum, the Titanic Museum. Anyone watch Game of Thrones? Have you seen? Yeah? Okay, cool. We had some Game of Thrones t-shirts down at the DevOps booth yesterday, and we've got a few there as well. Sort of Game of Thrones inspired. That's where they film Game of Thrones, that square building in the middle. That's the Game of Thrones studio, the Titanic Studios, they call it. And then don't let this worry you. My office is the office is just that big, long, pointy building near the battleship. That's where Microsoft's DevOps strategy comes from. And then big hole in the ground right next to it. That's where we built the Titanic. So hopefully this one will end better. But as we say, it worked when we last touched it, so it should be okay. Right. My team is spread across the world. So obviously Redmond, we have a lot of people in North Carolina. But we're all spread globally across the globe. I work on a thing called Visual Studio Team Services. So this is the same code base as Team Foundation Server, if you've heard about that. VSTS is our collaboration tool for engineering teams. So it gives you all your source code tracking, your agile planning, your dashboards. It gives you all your release management and things like that, and hooks into things like application insights to provide a lot of monitoring capabilities and all that sort of thing. So that's our core kind of DevOps collaboration solution that we sell. As you can tell, I'm not a salesperson at all. I'm in engineering, but that's what we sell to everybody to help them use. We also use it inside the business ourselves. So one of the changes Satya made when he came into Microsoft was to stop us using lots of different engineering systems and all this sort of stuff and doing our own proprietary things and try and get us as a company to use all of the tools that we're selling to you, our customers, but also collaborate together as one business and as one Microsoft. So it's been a big cultural shift inside the company, and that's all being enabled via Visual Studio Team Services. So Windows is developed on Team Services now. Office is, as well as Visual Studio Team Services itself, and Azure. So that's kind of like an inception moment, where VSTS is built and deployed using VSTS onto Azure, which is built and deployed using VSTS onto Azure, which runs on Windows, which is built and deployed using VSTS, which is hosted on Azure, which has a lot of Windows. So anyway, it's like, I don't know where it ends. We do have a backup in case things go horribly wrong, and we do something really bad that breaks everybody. I think it involves like a computer buried in a mountain somewhere in Nevada, but yeah, we'll be okay, hopefully. I said this was about 65,000 engineers coming to Microsoft when I submitted the talk, because I thought that was a cool title. and then realized instantly it was factually incorrect. Right now, as of the last time I did a check, we've got 75,713 active users in Microsoft. So that's engineers inside the business that are using VSTS every day of every week to actually ship the code. So you see it goes down at Christmas and Thanksgiving and things like that because we get less active because we're an American company. But right now, 75,717 people, which is a lot of people. And people get shouty if you take the system down, which we'll talk about in a bit. Our DevOps journey hasn't been, it's not something we did overnight. It's not some magic silver bullet that we just went, oh, DevOps, right, done. Check, we're there. Let's move on. We've set up CI/CD. We've got some monitoring in place. Yay, we're DevOps. That's not how it works at all. DevOps is one of these destinations that you never quite, you're always on a journey on. You never quite get to. And DevOps is all about continuously improving, continuously making your business better and making your engineering processes better. So it started in around about Team Foundation Server 2010 is when we started at, and that's Sprint 1. That's where it began, and where we aligned our sprints and became fully agile across the organization. We actually released as a public preview. I believe it doesn't seem that long ago, but it was 2012. I've got T-shirts older than that I still consider new, but anyway, that's because I'm old. And then we've gone through a whole different set of milestones since then. The big one that I still got the scars from is what we call 1ES, so this one engineering system, when we started moving the whole of Microsoft into VSTS as well. So that was obviously, we had a big uptake of internal users. And then we introduced extensibility. We quickly realized once we got a bunch of smart people like Office and these sorts of people who have huge engineering teams, we can't say no to them. We can't say, no, we're not going to build that feature. But it's way down our backlog because we care about everybody. We care about you guys just as much as the Office team and the Windows team. And so we're like, yeah, we'd like to do that strange feature that only Windows need, but it's way, way, way down our backlog. So instead, we built a big extensibility model that allows really, really rich extensibility into VSTS, and then they can build whatever they need and plug it in. So that was a big change in how we worked in 2015. And then in June 2016, we started work on a thing called GVFS, Git Virtual File System, which turns out Git was never designed for a repo the size of Windows. Linux is the biggest sort of open source case of using Git in production, and that's 0.6 gig. No, yeah, around about that for a repository size. The VSTS code base is about 3 gig, which is really, really, really pushing the limits of how Git works. And then Windows is 250 gig, okay? That's a big, and so there was some proper computer science that needed to get solved to get Git to scale to that size. So we created what's now called the GVFS project and open sourced it and contributed it back to the Git community. And it's a virtual file system driver, which allows you to do really big repos. Usually when talking to customers, I'm like, if this is a problem of yours and you're not one of our competitors, then it probably shouldn't be a problem. You probably shouldn't be having code bases this big. You should probably be splitting the code bases down. So it's not something I recommend for many people, but just know it's there and we use it in production and we have Windows using Git, which has led to all sorts of other product improvements as well. I'll tell you about. And then currently we're in Sprint 124. That ends this week, and then we start Sprint 125 the week after. We do 3-week sprints. So as we did our journey to DevOps, we kind of learned 5 rough habits, 5 kind of groups of things that we learned as we were doing this transition. And I'm kind of going to go through each one. Some of these are really just the next iteration of being agile, So things like being customer-focused, having team autonomy, and enterprise alignments, those sorts of things are just really, agile on steroids, second decade agile, as people call it in the office. Then we've got a set of practices that are particular to a more DevOps mindset. So having production first, always in mind, shift left's kind of agile as well, actually. Doing infrastructure as a flexible resource as well is a very DevOps kind of practice. So they're what we're going to go through today, and I'll tried to break them down into categories. So hopefully some of these lessons you can learn so it doesn't take you 7 years to do this transition. And other ones you can just laugh at us for, because how could you do something so silly? Right. First of all, let's talk about what I mean by customer-focused. And obviously, it's the simple stuff like you would expect, like listening to your customers, having a Stack Overflow site, being responsive, making sure we measure how responsive people are being when it comes to replying to Stack Overflow posts, that sort of thing. It means having a good Stack Overflow page that we actually have engineers on, and nice tags, and maintaining all these sorts of stuff. Yeah, that's all very customer-focused. And that kind of mentality is driven very much from the top down in the organization. Our senior management are always on these types of channels, are always very communicative with customers. And that spreads out into the organization and becomes a thing that's expected of teams. And teams are monitored as to how well they're performing in terms of, responding on these channels, that sort of thing. We also have what's called a customer champ. So for certain customers, high-load customers or customers with peculiar workloads, we assign them a champ in the engineering team. And that's a direct point of contact from certain customers into the engineering team. And we check in with them. And it helps build a sort of empathy and trust within the product team with real people. And for me as a product owner inside of the team, it's really, really great because I can build on, I can sense check things. Is this what my customers I know really want to do? So that's, again, instilled and spread out across the whole business. We don't have one team within our group that focuses on talking to customers. That's something we think everybody should do. It should be a core part of every team. We also have in-product feedback, so that's fine. But really, the customer focus of DevOps starts at our very definition of DevOps, which is the union of people, process, and tools to enable the continuous delivery of value to our customers. And you'll have seen Donovan say that a lot better than me on stage many, many times. But this is what we mean. It's taking the value and getting it into the customer's hands continuously. It's not about CI/CD, although that's an important part of it. Just continuous integration, continuous delivery. That is an important technological practice in DevOps. But DevOps is about getting the value into customers' hands as quickly as possible, getting feedback, and then iterating and improving. We have what we call a definition of done. When is a feature done? When is a particular part of work done? Is it done when you've finished coding? Is it done when it compiles? No. Is it done when you've checked in your unit tests? No, because you should have done that before you started coding. Is it done when when you've handed it off to the ops team? No. Our definition of done is it's live in production, it's collecting telemetry, and it's examining the hypothesis which motivated the deployment, okay? That's when we're done with a feature, when it's in production, collecting telemetry, examining the hypothesis so we can test if why we thought we were going to make that change is true or not. Did we make a good or bad change? And that's a very fundamental shift. When we started doing Agile, our definition of done was potentially shippable. Then it became shipped. And now it's shipped, in production, collecting telemetry, helping you test if this was a good change or not. So that was a process we went on, but it took us a while, but that's where we are now. And again, very, very customer focused. The team owns delivering the feature to the customer and owns the customer experience of that feature, okay? To help us do this, we collect data very broadly. This was just some graphs I pulled off the system, and I think it was quite alarming when I saw it. I think we're up to about 2 petabytes of telemetry data we're collecting per day. So we collect a bunch of information which allows us to ask questions of our data, allows us to analyze, test hypotheses without even doing code, which is the cheapest form of testing things. And for all that, we use Application Insights Analytics. I always have to look at the name on the screen there because we all call it Gusto because, it's code names and things. But Application Insights Analytics. We're great at naming, aren't we? And then, so we do lots of queries, and it allows us to do very, very, very fast queries over large data sets. So pretty awesome tool. That's what we use. It's in Azure. You can use it. It's great. While we collect lots of data, we report on the things that are important, which we bring up into dashboards. So we have this data that we can use to ask questions of, but then we track key performance indicators, I guess most people call them, so measures. And we only track what's important. There's some examples of some dashboards. What's important to us and what's not, which is really key. So things we track, again, very customer focused. How was the acquisition path? Where do customers drop out when they're coming into our system? Where do they fall out the system and don't turn into an account? Don't turn into somebody who's continuously using VSTS. You know, maybe you went in, signed up for an account, never came back for it. Maybe you kicked the tires, did a bit of version control, and never came back for it. These are sorts of things we want to know. What's your engagement with the product? How much are you using the product in different areas? When we add a new feature, how much are you using the feature? That sort of thing. And obviously, we measure things like satisfaction. If you ever have one of those prompts that pop up that say, would you like to give some feedback? Please do. It's helpful. We try not to give you that prompt more than once a year if we can avoid it. And it helps us measure satisfaction of features and what we call our Net Promoter Score, NPS score. So that's how we typically measure things as a standardized way of measuring satisfaction across Microsoft. And then we also measure a lot of steps in terms of the development process. So what's our time to build? The equivalent of pressing F5, how long does that take? We want to get that as short as possible. How long does it take to be able to test the code that you've written? Because you're in a loop, isn't it? That's how quickly you can change something, test if it works, change something, test if it works, and then check it in and deploy. Time to deploy is obviously very key, bringing that down. And time to get measurements. It's no good if you're deploying into production 10 times a day, if it takes you 6 months to be able to get the data back to be able to tell if it was a good or a bad change. You need to be able to learn as quickly as possible as well. On our live site health, the key measurements there are time to detect, communicate, and mitigate. Again, customer-focused metrics. How quickly did we tell there was a problem? And then we also do things like, did we detect the problem before customers, or did Twitter beat us? You know, so yeah. How quickly were we able to send a communication out? That doesn't just help you as customers have a bit of faith in us that we know what we're doing and we know when the site's up and down and things like that. But it also helps us because, turns out we're in dev tools. So unlike, a lot of people are in this conference, like the office guys and everything, our customers are amazing because they're all engineers as well. So we have the best customers ever. And if you come out and say, hey, we know there's a problem, we think it's with, some bizarre DNS bug or whatever, and we're working on fixing it, then we find, our customers tend to be incredibly understanding. We don't want them to have to be, but they are. More importantly, it also reduces the load on our customer support agents because you go, oh yeah, they know there's a problem, I'll come back and check and I'll know when there's going to be a fix. So again, it helps us provide the right level of customer support to everybody. I'll talk about SLAs per customer in a little bit and customer support metrics. What's really interesting is in some of the metrics we don't measure. And we don't measure these as managers in the company, and we don't ask teams what these are. So, some classics. We do not ask what people's original estimates were. We do not ask how much time you spent working on something. Because, hey, it turns out, if you measure people on how successful they are at estimating, they're just going to pad the estimates, If you tell people and you measure them on their completed hours, you're going to find their completed hours adds up to their time estimated plus time remaining. As a business, I don't care. I care about how much time is remaining. I don't care how much time somebody spent on something. And I don't really care if that time goes up. You know what I mean? I just want an honest view right now, today, when do you think this task's going to get finished? And we want to encourage people to be honest with that and not have to play a game. Obviously, like lines of code, nobody measures that sort of crazy stuff anymore, do they? No? Okay, good. And then things like numbers of bugs found. I don't care if you found 100 bugs in your sprint. Sorry, bugs. There you go. I'm trying to pronounce it in American rather than crazy English accent. If you found a number of defects within a sprint, there we go. How's voice translation? Yeah, it's coming along. we don't measure how many you found, we measure how many you've got left at the end of the sprint, how many you're carrying over. If you fix a load, great. Or if you've not done any, great. I don't care how many of you carrying. I mentioned customer SLAs. When we're looking at the performance of the system, once you've got a massively scaled system with millions of users, scaled across tens of data centers, it's, once you get a lot of volume, it's not easy to keep in the high 9s availability, don't get me wrong, because, when something's out for a few minutes, then your metrics will suddenly plummet. But it's rare that you get entire site outages. What you want to look at is the performance per customer. Individual customers, what's their experience like? And that's how we measure it. We measure our SLAs per customer. And then we focus on the ones that are below where we want them to be. And I did have an example of, where we'd reached out and detected a customer all prepared. And then at the weekend, a better one happened. This was a great one. One of my colleagues got pulled into the phone bridge, a live site incident, and said, hey, you're a customer champ for XYZ customer, and I'm not going to say who they are on stage on the recording, but you're the customer champ for XYZ customer. Have you any idea why they would be running a job, an API-level job, with admin rights, with warnings disabled, that's doing destructive deletes? And not deliberately, no. So, and because he's the customer champ, he was like, well, I know this guy. It's sort of 9:30 in Houston right now, or wherever he was. May not be in Houston, maybe somewhere else. And he picked up the phone and had his cell phone number, which was great. Just rang the customer. I was like, hey, Mr. VSTS admin for your massive company. Do you know you're running an admin job, which is doing destructive deletes? And then you get the, and then when he finally got up off the floor and was like, oh no, realized that wasn't what the customer expected to do, canceled the job. And then turns out when we delete data, we don't really delete data, because deleting data is really, really, really expensive thing to do. We mark it as needs to be deleted and let the computer delete it when it's ready. So we went and we said, computer, please don't delete this data. And we went and started restoring that data for the customer. It took us an entire weekend, but we got the customer back up and running. So Monday morning, that TFS admin still had a job, that VSTS admin still had a job, and we still have a customer to talk to for our customer champ. So that's good. We also do as I've already mentioned, we do build, measure, learn. So this is hypothesis-driven development. So we say, we believe this is what's going to happen. A classic example is in a shopping cart. If we make a button 50% bigger or bright red, then we believe sales will go up 20%. And they're always very business-driven metrics. It's not, it's not like a frameworky thing or a performance-y thing. It's all about business measurements. I say it's not about frameworks. Sometimes it is, because one of our things is how cost-effective we can run a service. So we might say, we believe that making this change will reduce the cost of running builds by 60%, in which case we'll invest in that change. But that's the sort of measurement we take. We take it at the business level. Because the feature team own the business. The feature team own the customer and own the business. It's not somebody else owning the business, somebody else owning customers, whatever. It's the feature team. When we are doing part of Build, Measure, Learn, this is one of the things that we started using to be able to do this. We need to be continuously integrating all the time. We need to be shipping code all the time. We ship multiple fixes per day out into production. We tend to ship every 3 weeks, like big sprint payloads every 3 weeks. So we need a way of being able to have code in production that isn't there, that isn't on yet, okay? And this is to save us having long-running branches, which then have integration pain later. So we use feature flags to take the integration pain early on in the process, but have it disabled for the customer. So we have a feature flag. Roughly speaking, feature flag, you come in, you've got a line of code, simple. You put an this is why. You put an if statement in the code, yeah? So if feature on. Sorry, it's not rocket science at all. It's not, DevOps is magic. It's just an if statement, okay? If feature flag is on, go do this stuff. And then we go do that stuff. We go implement that code base. And then what we tend to do, depending on the feature, we tend to make that user opt-in, so a user can switch that feature on and off. So you know quite often you're using some of our UI, you'll see, hey, there's such and such a new feature now. Would you like to use it? And you go, yes, please, I'll give it a try. And there's an admin, you can control which features are available to your org and all that sort of thing. So that's what we tend to do. We then switch on the feature, and we have the 2 code paths now still in the code base. And we need to make sure both those code paths still work. Both of those bits of code can still save data into the database and are non-destructive to each other. And then finally, we have a process in place that once we're happy that this feature works, we've proven that this is the correct feature, then we take it out and we remove the feature flag. So we remove the if statement. Because if we didn't, we'd just have a code base with millions and millions and millions of if statements, and you wouldn't know what was happening. Now, how do we know when it's complete? When we test the hypothesis to see if it's correct or not. Sometimes it's things like, we think this UI is a lot better than the old UI. We're going to make a massive UI change. What we do with those ones, we opt in, we measure the opt-out ratios, how many people opt out of this feature. And we make sure we've got that down low before we know that it's ready to be promoted. Then we promote the feature to the wider user base and actually get people to use it because, hey, we've found people who opt in don't opt out again, so it must be good. Then finally, once we have, say, 80, 95% people opted in, that's when we depreciate the old interface, take it out and switch it off and go back. And so that's how we keep making sure we're paying down our debt all the time. The feature flags, as I say, you can control down to the individual user and the account level as well. Quite often when we're beta testing with customers, we will enable a feature flag in their account, and then they can try a brand new feature. An example of this was when we introduced Git into TFS, Team Foundation Server, and VSTS. We actually introduced that. It came, I think it was TFS 2013 was the first on-premises release that it shipped in. But the code was in TFS 2012 Update 4. It was just behind a feature flag that was switched off because we hadn't finished testing it yet and we were still working on it. So, it's down there, and we were able to switch it on for our own internal users, make sure it worked, and other people who we were beta testing with, make sure it was working. And then once we were happy, take the feature flag out and make it on for everybody. And obviously, it's not like, rolling out an iTunes store upgrade or an Apple store upgrade or something. We have to be able to do this live and in production, and it's just a database update when we switch a feature flag on. It's not a big palaver. Is that even an American word? Probably not. There we go. And then, so there we go. One of the things that feature flags give us, and you can get a bit carried away with, is marketers love it because we can build an entire new amazing thing, amazing feature X. We can go build it. And then they can keep it behind a feature flag until an ignite or a connect or a build. And then they can have Scott Guthrie come up on stage and say, hey, I'm going to make available today XYZ feature. And then there's somebody behind the scenes who flips the bit in the database, and that feature's live. And it's like, ta-da! Isn't this amazing? It's great. Dark launches, they have a real sense of pizzazz, and everybody loves them. Turns out they're actually really hard to do, okay? So we did this one particular day because you can't beat production load to know what's going to happen, especially with a big new launch of a big new complicated feature. So we were doing demos. Guthrie was on stage. My boss, a guy called Brian Harry, was also on there. So Guthrie would be my grand boss, And then Brian Harry was on stage. And we switched the feature flags on. Now, for their account, they'd already been on for weeks, all through the testing, all through the rehearsals. They were on for their account, worked flawlessly, everything was great. We switched the feature flag on for everybody. Everybody starts using it while the keynote's on. And then all of a sudden, we detect some cascade issue, and the system went down during the keynote that the people are actually demoing on. And it starts locking and pausing and things, and you don't have a good day when that happens. And it turns out because of the keynote events and big marketing events, they drive a lot of traffic if you do them right, and so lots of people were trying it, and we were busy trying to restore the system, and we ended up having to switch the feature off, go fix some things, and blah, blah, blah. It wasn't a good day. So we don't do that now. What we tend to do is actually switch the feature flags on a day or two before the big event, So if you want to know what's going to happen, say we've got, next builds coming round or next big events coming round, next Ignite, just go and use Azure the night before the keynote or the morning of the keynote, and then tweet all the features, you know what I mean, and really spoil the marketeers, because we tend to switch them on beforehand now just to make sure the keynote's going to go okay. Right. Next one, production first mindset. So I've talked about how we can break the site really easily and what happens when we do. It's not a good day. We have what we call a live site incident, LSI, because we're Microsoft. We like our three-letter acronyms, or TLAs. And so we, on detection, we fire up a conference bridge. It's just a Skype call, nothing fancy. And we bring in what we call, again, another TLA, the DRI, directly responsible individual, the person on call, okay, for that feature team. They get brought into the call, and people are immediately trying to identify what the issue is, make sure that we are capturing the data that allow full root cause analysis. It's no good turning up to a review meeting after the event happened and saying, what happened, Chuck? Oh, well, I switched the computer off and on again and everything's good. That's not a valid root cause analysis, I need memory dumps, I need logs, I need to be able to capture all the data so that we can do a full RCA, root cause analysis. But mitigation is the key priority, making sure we get a customer back up and running. But it's, let me get this straight. This is the engineering team who built that feature get on the phone. During the business day, they have to be on the phone within 5 minutes. In the middle of the night, or like I was one time walking around Harry Potter World with my family, you've got 15 minutes to get onto the conference bridge if it's non-working hours. But during the day when you're on call, you've got 5 minutes. So, and it's the feature team. If you were trying to instill like a DevOps culture in your business, engineers don't like getting woken up out of bed in the middle of the night, okay? If you start doing that, then they're going to make sure the quality of the system's a lot higher, and they're going to make sure things are automated, Because devs don't do anything twice either. If you give me something to do twice, I'm just going to write a script to do it, So, yeah. When we're doing that, we obviously keep a log of all the actions that are performed to make sure we can help, again, with root cause analysis. And then for the really long ones, like when we have, when we have a horrible problem that's taken a long time to resolve, we have to start bringing plans in place for rotating people on the calls, because it's quite stressful being on an LSI call. And after about sort of 6 hours, you're definitely starting to get a bit, bit punchy, and you need to get cycled off and somebody else cycled in. So we have procedures in place. It's very rare that they do go that long, but we have procedures in place for calling somebody else on your team into the call and handing over and all those sorts of things. We also, as part of every LSI call, we create repair items. These are just work items. What are we going to do to make sure this never happens again? We can detect it quicker, and we can mitigate it quicker. They're the three things you're trying to happen. What can we do to prevent it, detect it, and mitigate it? And you create work items to say what we're going to do these things. They go onto the top of the feature team's backlog. They go above all features. And there's a 2-sprint rule for fixing your repair items. You have to get them done within 2 sprints because sometimes you're at the end of a sprint boundary, it's not quite fair. So it's a 2-sprint rule. You have to get these repair items fixed by. And we monitor that, and that's one of the things we track. When we do have an LSI, again, you're amazing. You're very understanding. We hate having to do this. It hurts me every time we do. But we try and be incredibly transparent with what went wrong. If you think what went wrong was like really stupid, then quite rightly you'll not be our customer anymore. But when you read in and you look at some of the things that they did, you're like, wow, that was actually, that was actually a pretty hard computer science problem, and well, they did a pretty good job of detecting it. And okay, I'm gonna, it helps build up the trust, because we've damaged the trust by breaking the site on you. So we need to be able to do what we can to restore it. So just be transparent. And those things aren't comfortable. It's a cultural thing, again, that has to be driven from the top down, because it's not something a junior engineer can just do and be 100% transparent. It has to be driven from the top down, and your business leaders want to be transparent and have them actually put their reputation on the line behind the service as to this is why it went down. Again, it's not great having to go to your boss and help understand and help her understand why something went wrong. So it's you as an engineer want to prevent that happening. When we are doing automation, when we're doing alerting, it's having automated alerts with a key to getting good at responding and bringing down that the time to detection. Again, if Twitter's my alerting mechanism, that's pretty fast. That's normally sub-second, but we want to get faster at that. So we invested a lot in alerting. When we first switched alerting on, it was horrible. It was just like, alerts were going off all the time, because it was just alert, CPU, alert, blah, blah, blah. So we had to do a lot of work tuning our alerts and making sure that every alert is actionable. Because if you don't, people just get used to alerts going off. If the alarm's always going off in your neighbor's house, then you're never going to go around and see if their neighbor's house is okay. But if the alarm goes off once every 10 years or has never been off, then there's a sense of urgency and you'll go around and see what's happening. So sense of urgency, make sure we reduce our alerting. Once we managed to reduce our alerting, that then also allowed us to build what we call the health model. So by identifying where in the application the alert's coming from, who is the team responsible for fixing that part of the product. And again, this was done very much iteratively learning by looking at escalations and making sure we go direct to the team. Because we're measuring mean time to mitigation, a big chunk of that is getting the right people on the phone. So we're trying to get there as quickly as possible. And because we turned our alerts and tweaked them, we managed to get to the point where we actually have the health model automatically fire up the conference bridge and dial the DRIs. So you get robo-dialed into a conference bridge to come and fix a problem. And so sometimes, there's a live site incident and you're the first person on the bridge, which is always quite worrying because it's on you now. When we go through, we obviously, we're going and we're looking at, like this one in particular was some error messages, and then we called the auto dialer. I mentioned some roles already. In our team, we have engineers and SREs. Now, we're all on the same feature team, but we have 2 career tracks. That's kind of how we group people. We have these DRIs who are within the team, and they're nominated. You're on a rota. And then we also had to put things in place like, if you've got a rota of DRIs and we also want to be an inclusive team, we need to make sure that if people have got back off parental leave and things, that maybe their DRI rota is reduced, or if they've got some family issue, we have mechanisms in place for reducing the number of times they're on rota, because we want to make sure this is sustainable. But we have this whole DRI process where we rotate weekly. There are 2 people who are the DRIs, the person and the backup, the primary and the secondary, and then they flip every 12 hours. So that's all we do. It's just a basic on-call pattern. One of the cool things is that when you're the DRI, you get this secure laptop that's like a custom-built, encrypted laptop that you can't use anything for apart from for access to production via several levels of biometrics and several factors of authentication, which is awesome. The engineers themselves only get production access on demand when they really, really need it, and there's an escalation process for getting them. If they really need some production access, then getting it to them, and then it's immediately revoked. We do have some SREs who permanently have production access. All of these people are vetted as well. We have vetting procedures in place that we go through to do stuff and to get all our certifications and whatnot. One of the lessons we learned fairly early on with I mentioned the SREs, they perform tasks which haven't been automated yet, okay? One of the lessons we learned early on was there's no such thing as partial automation, unfortunately. We used to, when we were doing, what should we do for a production deployment, we used to build up a OneNote. Microsoft lives on OneNote, Excel, and PowerPoint, and Outlook, basically. So we build up a OneNote, which contain these are the steps that we have to perform when we go to the different environments, and you'd have some scripts in there. You'd copy a bit of PowerShell, you'd stick it in the OneNote, you'd test it, it's great. But anybody tell me what's wrong with that bit of PowerShell? Hey, smart quotes. You come down to the booth later, I'll give you a sticker. Good man. So yeah, smart quotes. When you copy-paste stuff in, you get the little, things happening in OneNote, and all of a sudden your perfectly good PowerShell script is now non-functional. So imagine that happening dozens of times, and then late at night, deploying to your 15th data center that day, you accidentally miss one of the steps, that happened, okay? And we took production down for a day. It's not a good day, and it's not a very nice thing to have to write in an email and get your CVP to blog about, you know? So don't do that. There's no such thing as partial automation. We automate everything completely. Everything, nobody checks in a one-time command in production, even when you're resolving LSIs. You check them in so that there's a log of what you're doing, and that's how you run them. We use VSTS, release management, to deploy to the environments to run those scripts. And we go through a pre-production environment before we go into production. So all this is done using release management in VSTS. Our environments are in what we call rings. So I think we're in 15 data centers right now. There's one switched on. I think it's about 15. They're in 5 rings. The first ring is actually ring 1, is our canary ring. So that's where we live, the VSTS team. So if we deploy, and we deploy to it first. If we deploy something to the canary ring, we put quite a lot of load into it. We're going to find out first, and we're going to be the ones that are broke first, which is great. At least it wasn't, customers that have paid money for it. So I'd rather it was us first. Then we go into the second ring, and we pick our the smallest data center that's got real people on. So that, because then we can do a deployment to it quickly, and we can start getting non-Microsoft telemetry data back to let us know, is this working okay? Normally, once you've got past the canary ring, normally things are starting to go okay now. After you've done the smallest data center, it's just proper testing. You test the smallest value, then you test the biggest value, So then we go do our biggest data center and make sure that upgrade goes okay. Then in the fourth ring, we have international data centers where there's a high degree of latency between the data center we're talking to and where we're deploying from. And then finally, we do everything else in the mainland US. So that's kind of how we have our rings of deployment set up. Once you've done feature flags, once you've started monitoring things by account, it tends to go okay. You can generally, it's getting a lot better now. We're in a better place. But you want to make your service self-healing. You want to reduce the number of times that you have to actually page an engineer in the middle of the night and get them to fix something. It's much better if the computer itself can throttle back. If a service it's talking to is having performance problems, quite often it's better not to just not talk to that service anymore. Ideally, degrade gracefully. In the cases where you can't, it's still good to back off from the dependent service, because once you bring that service up, it's really hard to bring that service up if you're trying to also process a massive backlog of inbound requests. So you want to reduce the load on the service that's suffering problems so you can bring it back up again. And we use a thing called circuit breakers to do this. If you want to learn more, I've put a link. It's in the slides, but basically look up Hystrix from Netflix is an example of a circuit breaker model. That's what we use again to make sure we back off. Now, there's some tuning of circuit breakers you need to do, because sometimes you'll find like a customer's SLA going down there because a circuit breaker is getting triggered. And it's like circuit breakers in a house. They're putting a lot of load on a system. Is that load, can the system handle that load, yes or no? Maybe I could put a 13 amp fuse in instead of a 10 amp fuse or whatever. Or is it that my code is putting too much load on the system? That's what more often it is. And so I have to adjust a bit of code to fix it. And so quite often what you're detecting with a circuit breaker is you're detecting performance issues before they become outages. Okay? So you're able to fix something because you see a hot path occurring. You're able to fix it before it then becomes a breakage, which is the ideal. That's where we want to be. So this is life site culture, and this was a big change for us, and this was the major change. We went from shipping shrink-wrap products to shipping multiple times per day into the cloud. Now, we still ship shrink-wrap products. That's easy to say. We still do that. We take the code base that we have in the cloud, and we take it roughly every quarter, and we ship it to our on-premises customers for people who want to use TFS. But this was the biggest culture change that we had to do in the company, and it's taken us a while to get through, and we're still getting better at it. Yeah, so that's just a review of all the sort of stuff we talked about. Okay. Oh, yeah, this is cool. We also do pen testing, so red teaming. So we have periodic exercises where we have some of the best engineers in the company pitted against some more of the best engineers in the company. One's the red team, one's the blue team. Neither knows who's on which team. And with privileged insider information, but only using access methods available from outside of the network, the red team try and hack us. The blue team try and defend us, try and detect them hacking and write report on it and prevent them from doing it. And this is a great way of instilling this security mindset. You know, Microsoft's always very big into this anyway, but it's a great way of instilling the security mindset inside of the teams. Quite often I'll get emails, you know, that look a bit sketchy, and my natural assumption is it's my own red team trying to hack me via a phishing attack to get privilege escalation onto a system or something like that. They can do anything. Anything a hacker can do, they can do. So no rules apart from don't take a real customer out, but you can take out Microsoft, but don't take out, you know, paying customers. And yeah, that's about the main rule, really. So, yeah, and make sure you're only doing stuff that an external person can do, even if they had as much privileged knowledge as they do. Want some sobering information? The red team always win. And it's horrific. But it's so sobering as a business and as engineers, and even saying it now gives me goosebumps. Just the things, I've got some really smart people, the things that people do to get in, it gets increasingly hard for them to get in, thankfully, but they always get in. When we began, it was things like, hey, let's write a script which will crawl the network, and let's see if anybody's accidentally left passwords on a network, on a share that's accessible. And you find somebody once shared their C drive because they wanted to share somebody and forgotten they'd shared their C drive. And now, boom, they found a password file which is saved onto their disk, which again is a sackable offense, but they did it anyway. And then, boom, you know, they're in. Oops, okay, that was like phase one. Now we're on to, you know, 3 or 4 levels of exploits to try and get in, and then do privilege escalation, and then phish somebody to try and get them to go through a link which will do blah, blah, blah. You know, it's getting harder and harder. They always win. It's really upsetting. But it's because they're also awesome, so that's good. I mentioned Agile. When we started the Agile transition before we started DevOps, so we're kind of now into our 2nd decade of doing Agile. We are very, very mindful of giving teams autonomy. If you want to read a book called Drive, it's by a guy called Dan Pink. Great book. And there's also a YouTube video about it as well, actually. An RSA animates video of this and a TED Talk and stuff. But read the book. It's pretty cool. And one of the things it finds is that engineers aren't necessarily motivated by money, because engineering is a creative discipline. It's not just manufacturing. It's a creative art. They're not motivated by money. You have to give them enough. Don't get me wrong. If my manager's listening, you have to give me enough money for me not to worry about money, okay? But it's not purely about financial rewards. Unlike sales teams, and, you know, nobody here is the sales, does he? Okay, cool. Yeah, you know, not like the sales guys in suits. We tend to be motivated by shipping stuff that's awesome, solving hard problems, you know, and having learning, finishing the day smarter than you started the day. That's the sort of stuff that motivates us, you know, and as long as you can pay the bills, you tend to be very happy. So we deliberately give our teams autonomy over how they work. But we're a big company that's delivering big services to lots of people. We can't have complete anarchy. So we have to balance autonomy versus alignment within the business. So we give them full autonomy over what the plan is and how they deliver the plan. And then we have some certain sort of structure in place with which they can have complete freedom, a certain taxonomy in place, which we set up, which we have alignment of. So how does this work in principle? Oh no, let's talk about having too much autonomy first. I wanted to give you some horror tales. I mentioned I had some scars from when Windows came onto VSTS. This was one of my particular scars. The Windows team weren't in TFS for their work items. They're in a thing called Product Studio, which is some internal Microsoft thing, which actually TFS had their code base is originally from this product called Product Studio, which is an internal Microsoft tool. The Windows team were in a bunch of Product Studio databases all over. And they had a plan in place with a 2-year migration, or no, 1-year migration, sorry, that was but taken years to get to. That was like how we were going to migrate to one product studio database, because that's what we want to do. And we're, you know, big plan, lots of process, lots of training, lots of blah, blah, blah. And then Terry Myerson and Satya get together with my boss, Brian Harry, and decide, you know what we should do? One engineering system for the business. Let's get the Windows team into VSTS. How long do you need? Oh, let's give them 2 weeks, yeah? So, thanks, boss. So when that sort of thing happens, you tend to say yes to a lot of stuff you're going to regret later, you know? So all these teams come up with crazy like requests for how they do stuff. Yeah, sure. Just don't bother me. I'm trying to get you into our system right now. So you say yes to everything. The downside of that is you're basically building up debt, okay? You're building up process debt. And just to give you a very visual representation of process debt, this is what the Windows BRK, there you go. Do you understand what I'm saying? BRK? Is it translated okay? Anyway, defect. This is what the Windows defect looked like when we brought it in. Actually, no, sorry, let me scroll down a little bit. It was insane. And it had all these fields that anybody within the Windows org of like, you know, thousands of engineers, any field that any of them wanted, it would have in. Because yes, you know, come on. So it was like the worst of everybody's bugs, amalgam stuck together, okay? Not only that, like, we looked at the state models, you know? Like, what states did they have? Active, complete, those sorts of things. And this is what we found. Yep. And so, as engineers, really interesting exercise. We actually went and analyzed what they were using, and it turns out what everybody was using was totally different from what the managers were telling them to use. Because when you've got a process template like this, you just can't understand it. So you just route around failure as an engineer. That's your job. And so they would just stick blank data in or any data in. It wasn't any more accurate, but it was just insanely complicated and took them a lot of time. We did some analysis of how much time developers were spending in the systems, and they were spending just over 50% of their time doing the things you would think of as coding. Nearly 50% of their time was updating the work item tracking system. It's madness. So we had to fix that. And the way we fixed that, we had to do buy-in with a large org. So the Windows team set up what they call a Jedi Council, and that was the head of all the different engineering groups get together, and they basically argue between them about which fields should be deleted and which fields need to stay, and then we can just implement that for them. So that's how they did it, but it was a process of clearing up debt afterwards rather than up front. Let's talk about another way of how we organize our teams, because that's something that we have common across the entire engineering org inside of Microsoft. We start off with our team structure of having program management, and we used to have development and test. So it's PM, SDE, again, it's always TLAs, sorry, SDE and SDET, Software Development Engineering Test and Software Development Engineer. We got rid of those about 2-3 years ago, maybe more, actually. We just had one engineering career track, so everybody became an engineer. Engineers are now responsible for testing. Engineers are responsible for the quality of their code, running in production, collecting telemetry to decide if it's good or bad. We also have the ops team, again, and we want to make sure we're not just throwing things over to the ops team. You know, here you go, run my site for me. I'm going to go lie on the beach now. We needed to get them together, so we create what's called a feature team, and we bring people, PM, engineers, and ops together in one team, and they are the feature team that own a feature that's responsible for delivering to the customer. They own the customer experience for their area, nobody else. They're on the hook. We put our feature teams usually in one physical team room. So it's a room that the teams sit in, and then around the room we actually remodeled our office, and we put meeting rooms around the feature team room. So if you want to go make a phone call, if you want to get together and have a huddle with a couple of people, you can. But usually your team is in one place. We don't do follow the sun development. Even though we've got people all over the world working on VSTS, we put a feature team together, and they are responsible for delivering to delivering to people. We don't spread it out. We try and keep them together, just to improve that high bandwidth communication and make sure people feel part of one team. It's a two-pizza team, so 10 to 12 people. And And we keep the feature team intact for roughly 2 years, 18 months. Now, our business priorities don't stay intact for 12 to 18 months, you know. I wish, but we're in a fast-changing world. And so what we actually do is, if we decide we need to reprioritize what we're working on, we'll actually adjust the charter of a feature team. We'll give a feature team a different charter and help them work on something else. We don't split the team up, okay? So we keep the feature teams intact. We try and have our feature teams, as I say, own an entire feature all the way to production and all the way through the stack. It's not perfect. We do have a couple of teams that focus on a couple of layers, but we try and have it all the way through the stack. That's the ideal. Again, to the customer, delivering telemetry that tells you if you're right or wrong. Now, I mentioned we change our teams roughly every 18 months. We just did this last week. We do what's called a yellow sticky exercise, but we use different colored stickies, but there you go for first, second, and third choice. What we do is we have teams, we have the managers of the teams in place. These are the people you're going to be working for. This is what the charter of that team is. Then we allow our engineers and ops people to select where they work. It's quite a scary thing to do as management, okay? But it means each team has to have a charter that's interesting. It means each manager's got to make sure that they are awesome, because otherwise nobody will want to work with them. And it also means that the people themselves, everybody, all the engineers, get to select where they work. Quite often, it gives you this opportunity and choice about what you do. Quite often you don't actually change. Sometimes it's about, I think it's, what did I say? It's like less than 20% actually do change, because as a good manager, what you do is you campaign, you know what I mean? You go hunting people, and you're going to stay on the team, aren't you? And all this, so you bribe them with ice cream, whatever it takes to keep your team together. But it's good. It's an opportunity. It makes the team feel valued, makes everybody feel like they have a choice in their career, because they do. It makes them feel like they can manage their career inside of your team, which is important. The only way to manage a career, you don't want that to be by going outside of your company. You know, you want them to stay. You've recruited them. They're good. You want them to stay in the business. So we do this yellow sticky thing. It's fairly unique in Microsoft, but it's pretty awesome and cool, and we enjoy it, and it's always a social event as well. When we do our planning, we have an 18-month scenario, which is like our North Star vision. Where do we want to go? We then have these 6-month seasons or semesters. This is the most important planning thing. This is kind of where do we think we're going to go? And now your confidence is kind of like at the 40% error margin kind of now. This is roughly where we want to be. We then have a plan of where you're going to be in 3 sprints. And then finally, what are we going to do this sprint? What are we going to do this sprint is usually really, really accurate. The second sprint is kind of accurate, and third sprint tends to be, well, I think I'm going to do this, you know? And that tends to be your 3-sprint plan, delivering towards your 6-month season. As leadership, we own the big picture. Have we got the right teams working on the right thing? Have we got the right number of people in the right teams? All those sorts of things. And the teams themselves are responsible for everything else up to that 6-month plan. So everything, okay? Including what's on the backlog and what's not. So, and we have to trust them as the managers. You can influence them and say, well, I think you should really have this feature, please. But they are responsible for what's on their backlog. When we do the planning, it's continuous. So we go through, we do the sprint, we do 1 sprint, we keep on planning 3 sprints out. Where am I going to be in 3 more sprints? Keep planning. Then once we've finished a season, we then go and iterate, and we do the next 6-month planning session. And when we do that, we update our North Star as well. So we're continuously looking ahead about where we're going. Because a plan, like a plan's not useful. Planning is useful, okay? The plan itself is fairly useless because it'll change. But it's going through the thought process of planning where the value was. So that's what we do continuously. And if you look at like our value chain, the typical plan, you do a plan, all the value is early on, and then it becomes less valuable to you. It probably goes down after a while, to be honest. But yeah, you get most of the value in the first few weeks of planning. So by doing this, we take that high value period, and then we get rid of the less valuable period, and we just keep doing that over and over so that we get multiple releases. And then when we compare that with how we were doing before, we can see that we've delivered in that same time period, we've delivered a lot more. typically. That's the goal. How do we stay? We've got massive teams. How do we stay in sync between everybody? The best thing I like is that we do these sprint mails. So at the start, it's a bit like, in terms of Scrum ceremonies, it's a bit like a sprint planning session and a retrospective and a stakeholder review meeting all in one email. Because again, we've got lots of people, so we're trying to scale this. So we send out an email that has the plan, and I'll show you that. So there's an email there. Who's done it? What things have been accomplished this sprint? What we're going to do next sprint? Any issues? Any blockers? But the thing we do have is a sprint demo video. To be honest, I tend to just watch the video rather than reading the emails. If I'm, sometimes I'll drill into the email if it's something that doesn't feel right. But I quite often just watch a lot of the videos because I can get a good idea of to what people are doing. You can only do these videos when you're delivering things into production that benefit the customer. Because if you have a sprint video, which is a load of, I've made a new version of an API that nobody cares about, demo is not going to be very interesting. Yeah? The rule of your sprint video is as short as possible, definitely under 5 minutes, usually aim for about 2 to 3 minutes. No production quality whatsoever. We've got a lot of alpha nerds in Microsoft. When we first started doing this, we used to get like Star Wars credit sequences, dances, all sorts of crazy stuff, CGI. No, okay? I want a screen capture recorded as if you were doing an over-the-shoulder demo to me. I don't want any sequence shortening. I don't want to see, here's me creating a team project, and then 5 minutes elapse, here's the new project. I don't want it to appear instant if it's not. I want it recorded in real time. And they're the main rules, and that's what we do. And then we update and user voice, tell people it's been done. We go and update everything else. The next important thing we have is these team chats. So we talk about what's on the backlog. This is every 3 sprints. You talk to management. What's next? What's coming up in the next sprint? What's our debt look like? How many bugs am I carrying? And am I blocked? Standard sprinty kind of stuff. But we do these every 3 sprints because we've got a big team, and this is how we found it scaled for us. We do this direct into management. So as a group program manager, I delete a lot of email with PowerShell. I have to listen to lots of people's team chats to make sure there's coordination happening between teams. And so that happens direct. We don't go through management tiers and all that sort of stuff. The team themselves report what's going on. And then we have these experience reviews. This is the 6-month plan. Again, this is not an experience review for the whole system. This is the feature team's 6-month plan. What are they going to be delivering in 6 months? And typically, that's a lot of PowerPoint mock-ups. That's a lot of roughly this is the sprint we're going to be delivering it in roughly. We're dependent on some other thing arriving roughly around then. That's the kind of level of detail we do. We don't want massive 100-page specs. We don't want UML diagrams. We just want PowerPoint mock-ups showing you what the customer experience is going to be like in 6 months' time. And that's the opportunity for the team to get feedback from not just management, but their peers about are they doing the right thing, are they heading in the right direction. And by doing this, the team themselves are feeling a lot more, they own the customer experience. They are the ones saying what's going to happen in 6 months. It also gives us the ability to figure out, are we making progress? Is a team performing correctly? Are they making the right decisions? If they're consistently coming and not showing value, then let's tear that team down and we'll build a new team, Let's try and restructure something to fix it. Right, shift left. So I mentioned we have, we keep track of debt. The main one we look at is a berg cap. So based on how many engineers on your team, you have 5 defects per engineer. Okay, so, 5 times 10 is 50. Awesome. So you have to stay behind that rule, behind that bug cap. If you go above the bug cap, you go into bug jail, and you're not allowed to do any feature work next sprint. You've got to just pay down your defect debt. There you go. In the old days, before we went really agile, this is kind of the bug count for TFS 2010 when we shipped it. And you can sort of see peaks as we were doing testing up to a beta phase. Then you see them dropping down during stabilization when we ship the beta. Then you see a massive peak when we get loads of feedback. Then you see it going back down again when we shipped an RC. Then you see another peak, and then you see it going back down again. And that's very typical. You get these cycles of debt that build up. where you come in and you build up a thing and you pay it down and you have massive stabilization phases. And people just play games, you know. People like play what's called check-in chicken. You know, you're assuming that somebody else is going to be further behind than you are. You know you're not going to be allowed to add a new feature when you're into stabilization, so you just chuck in code that doesn't work, and then you fix it as a defect later. You know, we don't want to play those games. We want to be playing down the technical debt all the time, and that's what we do with sprints, and that's why we keep track of our technical debt to keep it low. We also want to change the amount of tests we do. We used to have a lot of end-to-end environment tests, you know, like integration tests kind of thing for UI automation. We needed to bring those down, and we wanted to make them repeatable across environments, so you could run these tests in production, and you could run them a lot, you know, they're a lot more stateless. So when we measured our test portfolio, we saw this, which was really horrific. So let me break down. L0, you can see on the slide here, L0 is what you would think of as a proper unit test, okay? L1 is a unit test with database access, but test database. And then you've got L2 is talking to a REST interface as if it's a contract. And then finally, L3 is like UI automation testing. So that was our balance of our test portfolio. And ideally, what we wanted it to be was a lot more weighted to the other side, a lot more L0 tests and a lot more L3 tests. So this is end-to-end how we did. And you can see it took us a long time. Let's have a look. From sprint 78 to sprint 120, well, I can't even work that out. That's a lot of weeks. Each sprint's 3 weeks long. It took us a long time to transfer that, but over time, we've moved our test debt. We've moved our tests. We've shifted them left, made a lot more integration tests, and made them a lot more repeatable. Now, anybody can run tests in production. We have very strict limits on how long tests can take. We want tests to be fast so that we can run them on every pull request. We want them to be reliable. If a test fails, then we get rid of the test and write a new test. You know, if the solution to fixing something is to rerun the build, then that's a bad test, so we get rid of it and do a better test next time. Talk about pull requests. We use Git now inside of Microsoft mostly. The Windows team moved on to Git. We've moved on to Git. We still develop TFVC. If you're using it, don't worry. I don't think in my career TFVC is going to go away, but we've moved over onto Git for all of our tooling. We use pull requests as our point of code review. And when we do a pull request, we run all our L0 and L1 tests. So we run all the unit tests, basically, as part of the pull request. We do this pre-merge, okay? So a pull request is before that code is in master, before that code is visible to everybody else. We run all of our unit tests, and we check it works. We also run compliance tests. So we have a thing called polycheck in Microsoft, which makes sure you haven't checked in swear words in somebody else's language or something like that, and a bunch of things. We have make sure you haven't checked in credentials accidentally, you know, just stuff like this. We have a bunch of compliance-y type tests as well that we run. We run all those pre-merge before the code is in main where everybody else lives. So this helps us keep master stable for the rest of everybody else. Only when the builds have succeeded and now all the tests have passed, does it then become eligible for code review? Does it then become where somebody actually reviews your code, have some comments, approves it, and you can set TFS, you can set VSTS up so that I require approval from a particular group before this is allowed to be merged and all those sorts of rules, and we have all those configured. The result of this now is that continuous integration tests are incredibly rare for us. PR, so build failures on a PR are fairly common, but you don't have to have the build bunny of shame or anything like that anymore, you know, because you haven't broken anybody. You don't break the build. All those tests have happened before you get through to master. Now, when we get to master is when we run the entire test suite. So sometimes things still get through, but if they do, then there was a fault in your unit test coverage, and so you improve your unit testing as a result of that. And then this is kind of what our pull request process looks like. Basically, lots of things happen pre-merge, and then once we have merged, we run a bunch more tests to make sure everything's happening, and we report on that. We deploy to a dev environment, and then it's a manual approval process to start the deployment out to production. You know, don't think that continuous delivery means it's always being auto-deployed to production. We actually have a manual step in there which says, yes, time to deploy. Finally, I'm going to talk about infrastructure as a flexible resource. This is a DevOps practice that we see people getting very interested in. It's something we're interested in as well, and it's something where this is the next level of maturity where we're getting better right now, but we've still got a long way to go. So the first thing we moved from, it used to be when you started in Microsoft, you got given a laptop and a honking workstation machine with, a whopping probably 16 megabytes of RAM back in those days, or whatever it was, and a 2 terabyte hard drive or something crazy, Woo! That's what used to happen. And then we moved from having everybody having their own dev machine under their desk to having VMs in the lab. And then we've moved from VMs in the lab to Azure DevTest now, which is our, the Azure DevTest environment. That's what we use to do our DevTest machines and set up VMs. And it's great because we have templates set up where I can go create a new DevTest machine that's connected to our corporate network through Azure, and then I can just stand up a dev machine in minutes. In fact, one time I was doing a demo for some customers, and you know how we all have these Ultrabooks now, and they're great because they're really thin and light, but you've got to carry about 3 kilos of dongles with you. So I popped home to grab my bag of dongles, and then went down to see the customer, and then realized I'd got my bag of dongles, but I'd left my laptop at home. And I was like, what do I do? So as I was walking to the customer, I went into Azure DevTest, fired up a VM to go get created, and then walked into the customer site and was like, hey, yeah, I was assuming I wouldn't be able to get connected to the network, so can you get me out to Azure? Is that okay? And then I can show you this demo. And they're like, sure, yeah, off you go. I was like, woohoo, I know what I'm doing. I'm not a complete idiot who loses my computer at home. We have a single code base that's TFS and VSTS. We have one code base that ships both cloud and on-prem, and that gives us some interesting issues about how we architect our code. So right now we have 2 main services. TFS is actually a service within VSTS, believe it or not. This is why we have all these different names. It's like internal stuff that's leaked out. That's where all your Git and work items and builds and things live. And then we have a common shared service, which is, we had to kind of rip these apart very, very painfully because we had a monolithic code base and we're trying to make it more service-orientated. So we kind of ripped it in half. And then that allows us to do data centers. So now we have sort of disaster recovery and failover and things, and we can get multi-data center, and that's all awesome. But as we're building new services, we're taking our monolithic code base and Dockerizing, containerizing a bunch of new services, and slowly taking our monolithic legacy application, which is not even 10 years old, and slowly, moving it over into containers. Why do we pick containers? Well, it gives us, we can ship cloud and on-prem, but it also gives us better cost because we can more densely pack our containers onto our VMs and things and still get redundancy. We can also scale them and we get serviceability through them. Right now, we've got a few services. We've got like 3 main services out in containers. We're still progressing on that. We're doing all new services of that. And we also, if you run a hosted build, a hosted Linux build, that's actually just running in a Docker container. So that's what we know. Right, time to wrap up. Important to say, DevOps isn't just this magic silver bullet, okay? I'm going to do DevOps, yay, unicorns and rainbows, even though I've got plenty of rainbows in my house. It's a journey. It's a journey that you go on that you're never going to get to. It's a journey of continual improvement. We have made lots of progress. I'm really proud to have worked with the team and got to where we are today. There's so much we've got to do. And, don't feel like, oh, wow, they've got blah, 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 and LSIs and magic machine learning bridges which DRI people in and all that sort of stuff. Just get people to start doing Agile. Just get people to start breaking things down into small chunks. It's a process. It's a journey that you're on. But when you do this, you can see a massive transition in your organization between shipping, every couple of years to shipping all the time, from having massive specs that are built up to having just, mock-ups that are done and then shipped, and to being much more customer-focused rather than being, fairly hands-off. Okay. Ooh, perfect timing. So please fill out your evals. I'm sure you've heard this about 1 million times this week already. I read everybody. My manager reads the scores, but I read every comment. So please, plenty of comments, especially about how bad my accent is and how hard I am to understand. That's awesome. And then, yeah, if you've got any questions, I'm going to head down the booth now so the next person can get ready for stage. But I'll be down by the DevOps area in the Microsoft bit. Feel free to come chat, but also drop me an email or, again, send me some abuse on Twitter if you want to get in touch and learn a bit more. Thank you very much for your time and enjoy the show.